have had a shopping cart component. However, if we later decided to add a shopping cart component, we could simply have done so using a singleton, since that is the fitting design pattern for the situation, and we could have just added it to our application just like we did in our code sample. Also, if we started off with a few different outfits but then decided we want to add the chain of responsibility to provide us with the in-season outfit just like we did in this course, we can easily do that at any stage in the development of the application. It does not necessarily need to be at the beginning stages of the design. If you go through sections 2 to 7 of this course, you can actually consider it as an existing application that we are adding a new component to, or modifying a component to, and doing so using a design pattern to make our code more extensible, maintainable, and testable at any stage in the development lifecycle. Adding design patterns to any project. Whether you're just starting off your project or you're working on a legacy application that's been in development for 15 years, there is always room for design patterns. Even if you're joining a new company or you're working at a startup or whatever the case may be, you can always add design patterns to your application. If you're still in the design phase, you should definitely use design patterns to have the best possible architecture in place, again, depending on the need.
Problem we're facing at the moment is that we're returning this string, and this string has to be converted into welcome.html in the templates folder under source main resources. I don't have one. Well, that's easy enough to fix. Here's source main resources templates. I will add a file. I could have added an HTML file, but I'll just write it out, called welcome.html. It is case sensitive. The name of that file is whatever the name of this string is, .html. And what am I going to put in here? Well, I'm going to add my HTML. Now, I'm going to paste this in. This is not a course on how to write HTML. So hang on 1 second. I'm going to grab that and I will paste it in, and then we will go on. Okay. What we have now is welcome.html. You could see it is an HTML5 file. It's got the root element HTML. The interesting part is this TH here. XMLNS stands for XML namespace. The colon then indicates we're defining a prefix that represents this namespace. Now, this namespace is a URI that represents the website for TimeLeaf. Now, a URI can be anything. There doesn't have to actually be a website there, but websites are convenient. The URL structure gives you a lot of information. So TH represents TimeLeaf. And then down here inside the H2 tag, you see we're using a text tag with the TH colon in front of it. This indicates that text here comes from time leaf, whereas the rest of this is just normal HTML. If we had what we call a validating parser for HTML, it would know that if it wanted to validate this, it would have to know the schema, the XML schema provided by Timeleaf. We're not going to get into all that, but this is the sort of thing we used to do. We used to plug in these extra tags and then have them compiled and converted as necessary. Now I have a head and a title, and in the body here, I have an H2 tag that has the text, and the text says hello plus, and then here's the magic part, $ curly braces user, and then an exclamation point at the end. That user variable here is the exact same thing as the user variable inside the model. Okay? So they're the same. Whatever I use as the key inside the model winds up being what I look up inside the view. Well, now I have a view. That's everything. In fact, if you look back at that hello controller, welcome's no longer showing a warning. In fact, when I mouse over it, IntelliJ Ultimate is smart enough to go, oh yeah, that's welcome.html under the templates folder under source main resources. Everything is now there. So I now have enough to actually run this application. In the next section, we'll run it inside the IDE. I'm also going to create, using my Gradle build, an output jar file and run it from the command line as well, just to show you both options there and look at a little bit of detail what's going on under the hood. But right now, between my hello controller and this welcome HTML page, I have an application. I've got my hello world ready to go. So I'll see you in the next section when we actually run it. So thanks. Welcome back. In this section, we're going to run our application, and as you'll see, there are multiple different ways to do that. The first and easiest one is to go back to that demo application class, the class in the root package that has the standard Java main method in it. Well, all we have to do is to execute that like any other Java application. Here I could use the keyboard shortcut, but I think I'll right-click and say Run Demo Application. And what you'll see is that the application gets built and starts up, and we get various messages over on the right, and there is Tomcat being initialized with port 8080. That's the default port for Tomcat. One of the things we'll see later is it's as easy to change that in Spring as to change pretty much anything else. But we did. We started up Tomcat on port 8080, and it took a little bit over 0.6 of a second, a little less than 0.7 of a second to start up. And I have a browser here. I'll go and put in my URL, which will be localhost :8080 / hello. That's the one that will trigger the say hello method in my controller. And sure enough, it replies with hello world. Now that one, I didn't give it a name. I just put in the URL without the query string. If I go back in and put at the end of that $name equals Dolly, then it says, hello, Dolly. It's so nice to have you back where you belong. Now, if you look inside this, if I go look at the page source, you will see this is straight HTML. The time leaf stuff is gone. That's what's different about using a template engine in a web app than doing RESTful web services like we'll do later and rendering JavaScript in order to build your UI. Here, this is old school, if you will. This is how we used to do things on the server side using a template engine like Java Server Pages. So at any rate, that seems to be working just fine. Let's run it a different way. So what I need to do now is, notice, by the way, this is still sitting here running, just going on and on. I want to run a different way, but before I do that, let me show you a nice little debugging step that can give you additional information about what's going on. Remember the file that's called application.properties under source main resources? This was another convention established by Spring Boot, is a standard properties file where we can configure the various Spring beans. One of the things I just mentioned that I could change here is server.port, for example, and you could see in the dropdown the default value is 8080. And if I wanted to run on a different port, I just put in a different number here, and that would change the URL. I also have Tomcat specific properties or servers like Jetty or Undertow as well. That's not the one I want to do right now. What I want to look at is something called logging.level. Now, logging.level, we'll look at a little bit more later, gives you a rich API for logging various packages inside your application. But you may notice here at the top, they built a web logging group called web. If I simply say logging.level.web equals and then hit control space, I have all the debugging and other log levels that you would expect. Debug, error, fatal, info, off, trace, or warn. I'll pick debug. Now this file is only read on startup and I haven't enabled any dynamic loading. So I'm just going to restart my application now. And it says, do you want to rerun? Yes, I do. And when it starts up again, now you'll see that there are some debug messages as well. Debug, debug, debug. And with weird long class names like request mapping handler adapter and request mapping handler mapping and all of that. That's not really the important thing I want to get to. What I want to do is say hello Dolly again. There. And now when I look in here, you'll see that at debug level, over here, there's debug level. We are logging something called the dispatcher servlet, which is receiving all the requests. And it says, oh, we received a GET request to /hello name equals Dolly. We map that to hello controller class say hello method that takes a string and a model. The output selected text/HTML as the output MIME type, and this was an OK HTTP OK response. That's an HTTP 200, and everything came back fine. This one line enabled all that debugging information, and it's very useful for debugging purposes, so good to use. Okay, let's look at another way to run this. The first thing I have to do is shut it down, because you can see it's still sitting there waiting for requests. There's no really graceful way to do that. I'll just hit the red stop button to shut it down here. And this time what I'm going to do is go to a terminal. I mean, I could do this inside the IDE, but I'm going to do it at a terminal instead. And I'm going to use that Gradle wrapper, Gradle W, and I'll use the command build. When I execute the build task, Gradle's going to compile everything, run all the tests. Again, our tests aren't doing anything yet. Generate an output artifact, and here's our output. You will now see, IntelliJ is good about showing you this, there's a build folder, and inside it we have all this stuff, including a folder called reports, tests, test. There's our test output. We don't have any tests running. There's nothing significant there. But what I want to show you is under this libs folder, LIBS rather, there's demo-0.0.1-snapshot.jar, and the same thing with a -plane.jar inside that folder. Now, if I look at the size of those things, so if I look under build libs, you see that the one that's got the -plane on it is only 2.5K. It's tiny. But the one that doesn't have -plane is 19 megabytes in size. And I've got one controller and one view. I mean, oh my goodness, what's in there? Well, that's a jar file. That, in fact, is our deployable jar file. If I go jar tapp, that's the listing one, and give it the path to that file. Whoop, didn't mean to hit enter there. Build libs.jar. What you'll see is inside that jar are all these libraries. I mean, there's and there's the big one, Tomcat, embedded right inside the jar file. There's the Jackson one for JSON parsing. There's logback or log4j. There's a YAML parser. There's a bunch of Spring ones, and more and more and more. The one that has -plane on it doesn't include any of that. It just has the code we wrote. But this one is the deployable jar. And I can run from that jar. Here's another way I'll fire up the application. I'll just use the Java command with -jar as a flag. And again, give it the path, build libs snapshot.jar. And you ready? I hit enter, and it started up. A lot of word wrap going on, but it's basically the same app starting up. Took a little under a second this time. I could just go to my browser and put in, a different name. Put in Jean-Luc Hello, Jean-Luc. See, I mean, it's still working. I still get my logging and everything. That's my executable jar file. That's what you could deploy to the cloud. And then on the cloud, all you need is a JVM because you're just running Java. You don't need to install a server or anything. Let me kill that with a control C. And then there's one final mechanism that works because I'm using Gradle. There's a special Gradle task called boot run that would allow me to run from the command line and then sit there waiting for anything to be built, and it doesn't generate that output artifact. But there's no great advantage to doing this, nothing over the ones that we already saw. So again, I'll just shut it down. So those are all the different ways to run it. Now there is one little issue here that I want to fix. Let me start it up again, and I'll show you the issue. We saw that I could run hello with a name or hello without a name and get hello world. But if I just go to localhost 8080, I get an error message. White label error page. The application has no explicit mapping for errors. So you're seeing this as a fallback. And this is a type not found. Status is 404. Let's fix that one. In the next section, we'll take care of that problem and run it again and make sure everything's working. So see you in a couple minutes, hopefully. Welcome back. The problem we identified at the end of the last section is that while we can go to the URL associated with a controller, the one that involves localhost 8080/hello, if we just go to plain old localhost 8080, we get nothing. Now, in regular web applications, according to the specification, what we need is a welcome page. No pun intended. So the idea now is to add an index page, a page called index.html, to the root of this project. Of course, we don't know where the root is exactly. Remember, we're building up a WAR file, except we're not even building a WAR file, we're building a jar file. You might wonder where the heck that page would go. It's actually very easy. In our app, application, we have source main resources, which is where we'll put all this stuff, cascading style sheets, JavaScript files, everything. We saw that the templates folder was used for a timeleaf template, something that's compiled and might be different on every single request, might be a different name each time. There's also a folder rather, called static, and that one is for anything that can be cached, that isn't going to change on a request by request basis. That's where we put our index page. So if I make a new file in that page or that directory called index.html, and I'm going to paste some code in here that I already had ready to go. Here is the index page I want to create. And let me walk you through it. Because again, this isn't a course on coding HTML. I just want to put something basic in here so we can go on. So once again, we have HTML5 and I'm writing it in English. Head, title, the title's hello world. And now in my body, what I'm going to say is, let's say hello. And what I have done is added, in fact, a form. Now let me maximize the file here so we can see it. This is a form whose method is using a GET request. That's the same thing we're doing in the browser when we just send a regular HTTP request. They're GET requests by default. If I wanted to change method to POST, we would have to have a POST mapping instead of a GET mapping. But right now, I just have a GET mapping. And our action is to go to that /hello, the say hello method in the hello controller. My inputs here, I have one of type text that has the ID and the name of name. That's going to be our input name that goes in the query string. And we have a submit button. Now, if you have done lots of front-end development, this is so trivial as to be kind of a joke. But what the heck, it's easy and it should get the job done. And that's what we want. So with that in mind, let me start up the application again. I'll use my keyboard shortcut this time. And now it's running. And this time, when I go to localhost 8080, I see my form. I mean, it's not much. It just says say hello and prompts you for a name. And when I put in Dolly here and hit say hello, you could see in the URL, it created the query string $name equals Dolly. And then that invoked our say hello method in our controller. And that's all we had to do. Anything you put under index.html in that static folder will be the welcome page in your app, and you could use whatever mechanism you want for that. Now I really do have a complete app, and I could refine it by adding cascading style sheets or whatever. Instead, what I'm going to do is I'm going to shut it down again. Let me just stop it. And in the next section, now we're going to do what I arguably should have been doing all along. which is writing tests for this. Once we know how to test it, then I can be sure and confident that it will run properly without having to go through this demo mechanism each time. These are not tests so far, these are demos. And I'd really like to do a test. And we'll start with a basic unit test and then move to a true integration type test involving Spring. And then finally, after we have our RESTful web service, we'll go to a full functional test. So that's coming up in the next section. Take care. Welcome back. One of the nice things about Spring is that it was designed with testing in mind. Now, we didn't do pure test-driven development. We didn't write tests ahead of time and then watch them fail and then complete the code to make it work, although we'll look at that approach later. When we look at our system so far, we only have one class. So therefore, we just need a single test to make sure that this is doing what we want. Now, we'll get into the issues of unit testing versus integration testing versus full functional testing. But one of the nice things about Spring, again, is that JUnit 5, the testing library, is bundled inside Spring automatically. It's part of the test starter that was added when we created our app. So here we have our hello controller, and to start off, just to demonstrate how these things are decoupled and I can write tests that work, we're going to make a test for this thing, just a simple unit test in this section, and in later sections we'll get onto more interesting, more powerful testing mechanisms. So in order to do a unit test for this, all I'm going to want is to instantiate the class and invoke the say hello method. The complication there is that while it's easy enough to provide a name, it's just a string, model's an interface, so I'm going to have to pick a class from the library that implements the model interface and use that as a second argument. I need that because because remember, we invoke add attribute on it, and I can't therefore use a null, or this would throw a null pointer exception. I've got to provide something in reality, and then I could check that the string welcome is returned by this. And if I do provide a model, I can verify that it will then have an attribute called user with the supplied name. So I will go ahead and go in the class name here, and I will hit Alt Enter and create a test. And the testing library is already assumed to be JUnit 5, and that is exactly what I want. Now, the name of the test is Hello Controller Test. I'm going to make it Hello Controller. Is Hello Controller Unit 5, and I will hit Alt Enter and create a test. And the testing library is already assumed to be JUnit 5, and that is exactly what I want. Now, the name of the test is Hello Controller Test. I'm going to make it Hello Controller Unit Test to make it very clear to anybody reading this exactly what it is we're testing. So I'll check the little method here. I don't need any setup or teardown, and I'll say OK. And now you see that we have Hello Controller Unit Tests, and this is located under the source test Java hierarchy in the controllers package, the same package where our controller exists. The import statement is already importing the test annotation from JUnit Jupyter, as well as doing a static import of the assertions. So what I'm going to do here, and my little AI client is trying to help me, and this is one of the cases where it helps some and gets some things wrong. Let me show you what it's doing. What it's doing here is it's saying, okay, let's instantiate the controller, and then I want to invoke say hello, and the first argument's a string, but it guessed wrong for the second argument. It doesn't know what to do, so it put in a null, and there's my assert equals to verify that the return string is welcome. Well, this isn't going to work, and I could run just that test just to demonstrate it, and you will see that, in fact, I did get a null pointer exception because I provided the null for the model, or the test did, and then we try to invoke add attribute on it. So that's not going to work. However, I can say, okay, model, the import from Spring Framework UI, model equals, and it turns out that one of the classes in the library that implements the model interface is this one right here called binding aware model map. Now, I found that out because I went back to my controller and I just printed out the name of the model class that was supplied by Spring when I was invoking the controller. I'm just not showing that right now. And it turned out to be this one, the binding aware model map. Well, now I've got a model. So let me plug the model in here. And now I can check the result, and I can also check that if I take that model and convert it to a Java map and invoke the get method on it with the user key, then that will return the proper name. That's now I found that out because I went back to my controller and I just printed out the name of the model class that was supplied by Spring when I was invoking the controller. I'm just not showing that right now. And it turned out to be this one, the binding aware model map. Well, now I've got a model. So let me plug the model in here. And now I can check the result. And I can also check that if I take that model and convert it to a Java map and invoke the get method on it with the user key, then that will return the proper name. That's one way to do it. An alternative, which is also valid, is to say get attribute with user. Same idea. So if I run my test again this time, now it works. Everything passed, and I know I'm okay. Now, this is very limited. It's like necessary, but not sufficient. You know, if this hadn't passed, that would be really bad. But if it does pass, it's not really enough because you see what parts of the controller we ignored. We didn't do anything with that controller annotation or the get mapping or the URL. All we're doing is instantiating a class and invoking a method manually and verifying that everything about it works. We'll get to that part in the next section. But one last thing to do here. One of the nice features of JUnit 5 is that it has a test method called assert all. Right now, I'm doing 2 consecutive assert equals, and the downside to that is if the first one failed, the second one would not get executed. It would simply fail the test right there. And I want to run both of them, even if one or both fail. So in JUnit 5, I could say assert all, which takes a series of executables, I guess you'd say. And here they are. Let's make that full screen. These are an executable is a lambda that takes no arguments and on the right hand side invokes a function that returns null. Well, assert equals returns null. We're good on this. So those are the same 2 assert equals, but wrapped inside the assert all. And now when I run the test again, it will pass, but it's an illustration that because we have JUnit 5, we have extra capabilities. And this is built right into Spring. So there you go for the basic unit test on our controller. In the next section, we'll use a really nice feature from Spring called mock MVC tests for that. And that's coming up next. So see you in that section. In this section, I want to use a capability from Spring known as mock MVC testing. It's a good capability to know anyway, but it's also finally going to introduce us to true auto wiring in Spring, and that's a topic we're going to use over and over again. Now I'm looking right here at the regular documentation, the reference guide for Spring on the current version. And there's a section in here in the testing overall portion called mock MVC. They say the Spring MVC test framework, also known as mock MVC, provides support for testing Spring MVC applications. And what it does is it operates in a mock environment. So if you need a request or a session or anything else, Spring is providing mock objects for all those things. The test is going to look like we're driving the system programmatically, like a black box, but there's no actual server involved. Now, much of what's done in this is done through static imports, these mock MVC request builders, the mock MVC result matchers, and we're going to invoke methods from those classes. Now, the setup, I now know I can ignore because they talk about it in the Spring documentation, and very typical of this stuff, in the Spring Boot documentation, they show a much simpler way. So I'll rely on the simpler way in Spring Boot. Now, how do I perform a request? Well, there's on the mock MVC object, once I get one, I can perform, and then this post here is what is mock MVC testing. It's a good capability to know anyway, but it's also finally going to introduce us to true auto wiring in Spring, and that's a topic we're going to use over and over again. Now, I'm looking right here at the regular documentation, the reference guide for Spring on the current version, and there's a section in here in the testing overall portion called mock MVC. They say the Spring MVC test framework, also known as mock MVC, provides support for testing Spring MVC applications. And what it does is it operates in a mock environment. So if you need a request or a session or anything else, Spring is providing mock objects for all those things. The test is going to look like we're driving the system programmatically, like a black box, but there's no actual server involved. Now, much of what's done in this is done through static imports, these mock MVC request builders, the mock MVC result matchers, and we're going to invoke methods from those classes. Now, the setup, I now know I can ignore because they talk about it in the Spring documentation, and very typical of this stuff, in the Spring Boot documentation, they show a much simpler way. So I'll rely on the simpler way in Spring Boot. Now, how do I perform a request? Well, there's on the mock MVC object, once I get one, I can perform And then this post here is one of those mock MVC request matchers. It's looking at a URL with a little wildcard in it, this HTTP template. The ID is 42. That's plugging in the value, setting the accept header. This is for a RESTful web service, clearly. Whereas if I look down here, here's one that's doing a GET request for something that looks like what we have, where we have a query string instead. And you could plug in the value this way, or you could use a .param method.
So inside, if you bump it around, it's got, I think, like a gyroscope. It's going to cut off. And from what I can tell, it's and lasers and then low power. But let me get an example of cameras. And with CO2 machines, you're going to need two. And when you're talking those, all right, so our next price range is going, but still you're not going to have just like the raw work area size like you will with those budget industrial machines. So really I go this route. If someone comes to me, they're like, hey, I can spend a pretty good amount of money, and I just, from that is going to be the Flux Hexa. I've done a full
and assign it that way, and that adds query parameters. Looking at the results, then you can say and expect, and this will use a mock MVC result matcher, status is okay, and that's a 200. And you could also find out what view page you're going to and what values have been added, what attributes have been added to the model. All right, that's the Spring part. Over in Spring Boot, we have a section called Auto-Configured Spring MVC Tests. Again, this is in the Spring Boot reference documentation. And they say to test whether Spring MVC controllers are working as expected, use @WebMVC_test annotation. That limits the scan to just relevant things like our controller, and even better, it tells us that it also auto-configures mock MVC. So all we have to do, like in the sample they show here, is say @WebMVC_test on our controller, and then we can auto-wire in our mock MVC instance. Now let's do it, and then I'll explain what that's actually doing. So over here, I've already got the unit test. In the same package, I'm going to add a class called Hello Controller Mock MVC Test. Might as well give it a complete name. That way somebody reading this will know exactly what it's for. And I will annotate it with Web MVC Test for the Hello Controller. And that will allow me to do what we just saw, auto-wired mock MVC instance called MVC. Now let me explain what that means. The auto-wired annotation is communicating with the Spring framework. It says, hey, Spring, I have introduced a dependency of type mock MVC in my bean here. Do you have an instance of that class in the application context? And if you do, inject it right here. So in fact, the first test I'm going to add here, the first JUnit 5 test I'm going to add is just to say auto wiring worked. You don't have to do this, but it's effective. Assert not null MVC. And I'll put in my static import. So that added the static import of assertion as assert not null. So let me run this test and see whether or not it's so that added the static import of assertion as assert not null. So let me run this test and see whether or not it's null, and it worked. So the auto wiring was effective. Now, if that didn't work, all my tests are going to fail. But okay, I've got something here. Now what I want to do is to go ahead and put in the tests. That's going to require the import of the request matchers and the result matchers. In other words, it's easier if I just paste in the imports for those right away. So this is the mock MVC request builders.get, and this is all the mock MVC result matchers. So I basically, IntelliJ is very good at adding imports for regular classes, but it's not great at detecting standard or static imports. So I'm adding that myself. All right, let's add a test here to say void test hello without name. And I believe I do have to say throws an exception for these, because the method we're going to invoke is mbc.perform. And perform takes as an argument one of those request builders. And I want to do the get method, and I'm going to /hello. Remember, that is in our controller the URL, the get mapping that's lined up with the say hello method. So there's hello, and now I could say dot and expect that the status is okay. That means we're going to get back a 200. And also that the view has a name of welcome. Remember, we're returning the string welcome, and that's going to be the name of the view. And I could even go and expect that the model has an attribute called user whose value is world. Great. Now let me run this test again, and you will see that that should pass. Good. That's a relief. So it did, in fact, do what it said, and this looks like we're driving it programmatically, just that there's no actual server involved. Now, to test it with a name, I'll just copy and paste here. Copy this and paste it, and this will be with a name. And then remember, I can do a .param, or I can do a let me change the URL in this case. So question mark name equals curly braces name, and I can put in the value of the variable right as the second argument. So that was one of the examples we saw. So again, the status will be okay. The same view comes out. The model will have an attribute called user called whose value is Dolly this time. So now let me run all three tests, and they should all pass, and we're good. Now, we may look at these mock MVC tests a little bit more when we move to our RESTful web service and start getting a little bit more sophisticated. But the real benefit of these is that you don't have any delay for the startup and shutdown of an actual test server. So these are still mocks. I mean, they're still using a mock infrastructure. I'd still call it an integration test because Spring is involved, but it's a lot closer to reality. The next step would be to do full functional tests. We'll get to that, but I want to first create a RESTful web service, and then we'll use our full functional test on that. I wanted to get to the RESTful web service anyway, and that'll be the next step. So I'll see you there. Welcome back. In this section, I want to put together a trivial RESTful web service. It's only going to respond to GET requests, but it'll give us back an object, and we can serialize that object to JSON data, JavaScript object notation, and verify that everything's working. We'll do the testing for it in the next section so that we could see how full functional tests work in Spring. So once again, we're not going to do the testing by writing the test first and watching it fail, but we'll do that later. Right now, we're still building up basic infrastructure. So I'm going to my controllers package again in my project, and I'm going to make a new class, which I'm going to call Hello REST Controller. And before, I added an annotation that said controller. This time, it's going to be REST Controller. Now, the docs on REST Controller annotation are not all that helpful. When you look at it, it says, it's a convenience annotation that is itself annotated with that controller, which is true. A REST controller is a controller, so everything a controller can do, so can a REST controller. And response body. And you're like, wait a minute, what's response body? And they say, well, methods that carry this annotation, or types that carry this annotation, assume response body semantics by default. And again, that doesn't really explain what's going on. Here's the bottom line. With the regular controller, we redirected to a view, or we forwarded to a view. With a REST controller, we're going to return an object, and that object will automatically get serialized into JSON data and dumped into the output stream automatically. We don't have to do anything special to make that happen. Now, this is a case where Spring Boot is helping us because we need a library to convert an object into JSON data and then parse the JSON data back into an object if we need to. And if you look at the Gradle build and you look at the compile class path, the web starter includes the JSON starter that was brought in automatically. The JSON starter includes 4 different dependencies that come from the Jackson JSON library. So the Jackson JSON library is going to automatically do the parsing for us. We didn't have to do anything. That's the default. Even better, we don't have to configure it because with Spring Boot, configuration is done based on the class path. That library is on the class path. We're good. So now we need something to return. I don't want to just return a string this time because the JSON representation of a string is just the string. There's nothing there. So what I'm going to do is introduce a feature that is unique to Java 17. This is the first thing we're going to add that is not available in Java 11 or Java 8. In fact, it was added in Java 16, but we're on Java 17 now. And that is a record. Now, a record is a data holder, and it allows us to put data in an object that we would normally have called a POJO, but it's got a ton of auto-generated code in it, plus it's immutable. So I'm going to put this, rather than putting it in its own file and making it public, because this is a simple Hello World app, I'm going to write it right in the same file right here. I just can't make it public. I can only have one public class per file. And that way we can look at it while we're writing our controller. So this will be a record called greeting, which will take a string, which I'll call message, and that's it. It's done. Now, here are the features about records that you need to know. First of all, they're immutable. Once you've instantiated a record, I can never change that message. That's done. Secondly, it auto-generates a toString method, an equals method, and a hashcode method for us. So those are typical methods we add to POJOs, especially if there's any chance of string output. We don't have to this time. They're all auto-generated. Third, you'll notice the constructor is outside the braces. This is the primary constructor. If I put a constructor between the braces, it has to delegate to that one. But this defines the properties. And that's the other thing you have to know. In POJOs, we would have a method called getMessage, for example, or setMessage. Well, we're not going to have a setter in a record because they're immutable. But even the getter's not called getMessage. They change the convention for Java Beans. Here, the name of the method will just be message by itself with parentheses. But let's go ahead and build our controller. So the controller is going to be a public method that returns a greeting, and I'll call it greet, and I'll put in my string name again. And all I have to do is instantiate the greeting class with hello name with an exclamation point. I'm not even going to do a formatted string. Just this is as simple as it gets, right? Pretty good. And the very fact that I return an instance of this class will tell Spring that because I'm in a REST controller, it should convert that instance into JavaScript object notation and put it in the output stream. Now let me add my normal annotations to connect this to the outside world. We'll do a get mapping to /rest just so it's really explicit to a reader where we're going with this. This is a RESTful web service. And then also for the name, let me add in my request param again with, just as before, the default value being world. And there we have it. So that is, believe it or not, that's the entire controller. I'm done. All I have to do is connect this to the world like I did, extract the parameter if it exists, or provide a fallback if it doesn't, instantiate the greeting and return it. Now, in the next section, we'll get to a full test, but let me at least demonstrate that this is working. I switch back to demo application, the class with the main method in it, and let me start it up. And here we go. So the class runs, everything runs here, and the application started. And now what I need to do is to go to a browser, localhost 8080/rest, and there you go. There's my greeting rendered in JSON form with a message of hello world. And if I put $name equals Dolly, then it uses that name instead of the default name that I had before. Now that's just a demo. As I say, we do need a test. And also, I don't have anything here that's working with post, put, or deletes yet. We'll get to that later. But it's a nice demo. Remember, we also added the web logging capability in application.properties, the logging.level.web equals debug. So that means when I look in here, I could see, yes, we did a get request to /rest name equals Dolly. It got mapped to hello rest controller's greet method. And our return type was JSON data here. See, that's the default. We can change it, but right now we're using JSON data. It says we're writing, and this is the toString method that comes with a record. And we got back at 200, okay. So everything's working. We're good. In the next section, we'll put in a full functional test so that we can not just demonstrate this, but verify that it's working just fine. So that's coming up next. Take care. Welcome back. We currently have a RESTful web service, and in order to test it, rather than just do a demo, I'd like to do a full functional test. In other words, a test in Spring with a running server. Now that might sound like a lot of work, setting up a server and deploying our application and then executing our
Coming Intro to Ruby on Rails series. And here to help us is Mr. Manny Rodriguez. So Manny, what would one expect to learn in this Intro to Ruby on Rails series?
Well, Justin, in this series, we're going to cover Ruby on Rails, starting from a blank app.
this segment, we're going to take a brief look at our upcoming Intro to Ruby on Rails series. And here to help us is Mr. Manny Rodriguez. So, Manny, what would...
Sources, RESTful. For this series, it'd be, you really want to have some experience with web development.
How are you doing today, Manny?
I'm doing great, Justin. It's great to be here. How are you doing?
I am doing fantastic, Manny. Actually, I'm really excited because...
Page, I happened to find one related to dachshunds, so here we go. But the reason why I'm bringing this up is because on this site, this page will never change. This is going to stay the way it is for all time until you go in with an HTML editor and actually change the text on your page. So that's why we call this a static website. In 2 weeks from now, if the webmaster hasn't updated it, I'm going to come back here. It's going to look exactly the same as it does now. Now, if I hop on over to Google and just do a Google search, maybe if I search for dachshunds, and already you'll notice that things are happening. I started typing in the letters D-A-C-H, and this whole search window popped up here. And it's giving me results about things I might want to look for related to dachshunds. So this is a dynamic website. And of course, if I execute this search, then I see a web page, but depending on what I type up here, so if I change my search to dachshund miniature, now I've got a different set of search results. In terms of what it actually is under the hood, it works pretty much under the same principles that Facebook runs under.
All right, so we're kind of splitting hairs on semantics. Now, I do want to back up a little bit. You talked about Ruby on Rails, the static versus dynamic, and you've shown us some wonderful examples. But, I've said a word a couple of times, Ruby. Well, Ruby on Rails is a framework, which we're going to get back to. But what is Ruby? What's the Ruby part of that?
Yeah, it's right there in the name, right? Ruby on Rails. And in this community, they're used synonymously, Ruby and Ruby on Rails. Many people think that if you're referring to Rails, then Ruby on Rails like it's one thing. But actually, they're different. Ruby is a programming language, a scripting language, that is used as a basis for Ruby on Rails. So Ruby on Rails is one framework that's written with the Ruby language, but there are others. Some of my favorites are Sinatra, which is basically a greatly reduced, simplified version of Ruby on Rails. And I really enjoy using Ruby for shell script editing as well.
So Ruby is akin to like Python or...
But it's kind
of just playing around. Now, I do want to move forward on this framework thing. I've used some frameworks, but can we dive a little...
Something in the same amount of time that whatever amount of time that you have, that's just way more effective. So a library is code that someone else wrote that can...
How does Ruby on Rails compare to those others?
Great question. Ruby on Rails, Sinatra, Express, those are all back-end web development frameworks. And a little further into the series, we'll talk about what that means and not spend a lot of time writing boilerplate so that...
I really like Flask, or I really like Django, or I really like...
programming language. It's such a sweet language to work with.
What could you show me?
All right, Justin, well, great question. And
Greetings, everyone, and welcome to another exciting...
top of that, our train's gonna run. So we're gonna kind of command, what kind of things can it do, and we'll be using this quite a bit in just a little while. But as you can see here, type in Ruby -- version. We talked a little bit about libraries in the past. Again, it kind of flows with the nature of a framework and what a framework is, or a library, what a library is. These are software packages that others have written that will support tools that support Rails. So it's kind of like we're laying down the track, and before we can lay down the track, we've got to get our planks, we've got to get our bolts and our nails, and then we're going to put track on top of that, and then on top of that, our train's going to run. So we're going to kind of really get down into it today, into the nitty gritty.
All right, so we got to get these first few things set up. So, well, I'm ready. You said we're going to install the Ruby language.
Yeah.
How are we going to get that installed?
Great. So we'll start with OS X. I'm on a Mac, and today we're going to cover Mac and Linux install. Good thing is if you're on a Mac and you're looking for Ruby, it comes with it. It's already installed. You don't have to do anything. If you can go to the Apple Store and walk up to one of their computers and do what I'm about to do right now, which is, if I've got a terminal opened up, it's a case. So, and we'll be using, for speed reasons, have some code that's written in systems kind of based off of Xcode. So you can download Xcode from the Mac. Select. And what this is just to break this down a little bit. What it's really doing is and one thing about the install Ruby and Ruby Dev, it'll basically show you what packages are going to be installed. You'll see on a page like this, either on the page of Giants theme, it would be, strictly speaking, you don't need a database for Rails, but we certainly do, because the become files on a hard drive that can be backed up and can be copied. 3 on OS X is that just like Ruby and Ruby Gems, it comes already installed on the system. So we don't need to install anything to get SQLite. And I was kind of guessing on there. I do this a lot. Sometimes you type in a package and you think the name should be this, but it's actually not that. So I'm just going to just double check my notes real quick to see what the actual, like all Ruby packages, Ruby Gems packages, we can see it here on what Rails is made up of. We can do that by using this dep command.
And maybe a little more complicated to get things set up. But is that an accurate assumption as well?
Yeah, Justin, that's accurate. To be totally honest, I don't have a lot of experience with Ruby on Rails in Windows. But if you think about the operating systems and their different histories,
To set up a basic, you'll notice that Manny's running Ubuntu in a windowed box.
Yeah.
And that's because it's a virtual machine. You could probably go through this series and do a fair amount.
So go ahead and go through that, install the Xcode tools, and then you'll have write an app that will do some graphics work. And we'll need to install a graphics library. And the graphics gem that we want to use uses some other package that Apple didn't include, installed on your computer already. So you actually, let me correct that. I've installed the packages that we're talking about on here now, but we're going to go through that process in Linux. But unlike OS X, most Linux distributions don't come with Ruby pre-installed. And some of them, you can choose them as an install option. They're just apt-get packages, and we're going to be running through a few of those now. So to start us off, we're going to want to, we're going to need root to install Ruby. So we'll do apt-get install, and I'm going to break this down into several different apt-get package installations, because I think it's useful to kind of group what we're installing together. Sudo, we're basically saying run this command with elevated privileges so it can do what it needs to do. Apt-get is our command line program to install packages, and we're telling it to install, and now we can give it a list of the things that we want it to install. So to start off with, we're just going to do Ruby and Ruby dev. So Ruby, this includes the Ruby programming language, Ruby gems, and all that associated stuff. Ruby dev is a set of development libraries that we'll need down the road to support the building of other gems. So we're kind of doing the similar theme as the OS X install. We're just starting a couple steps back. So it wants my password, I'll give it to it. And as I said, I've already installed these packages. So it's just confirming that, to me, that I've already installed it. It's the latest version. On your machine, you'll probably see something like a confirmation screen that'll show you it'll ask you what it is that you've got. So, for example, I just did a sudo apt-get install PHP. Say I'm just really hitting the web dev hard and I want everything. And this is what you'll see if you haven't installed Ruby and Ruby Dev. It'll basically show you what packages are going to be installed as a dependency for this package that you want. So it knows, based on what you've asked it for, it knows what it needs to grab to support you. And then it just kind of gives you a nice summary of what it's going to download and what it's going to do. So after we've done that for Ruby and Ruby Dev, now we've got Ruby, just like on Mac, and now it's waiting for me to type in a program. And I can do Ruby -- version, just like the Mac version. It works the same, and for this series, I'll be working mostly in OS X, but these command line commands are going to be the same between Linux and OS X. And of course, we've got gem as well, and it works just the same as the OS X version. All right, so we're here in Linux. We've got Ruby gems. We need our development libraries. So just like, in OS X, Apple hides some of this from us because a lot of the packages that I'm about to type in to get in Linux, Apple's already included with Xcode. So this is kind of cool because we'll get to learn a little bit more about what's behind the scenes here. And the packages that we need are libxml, libxml2, libxml2 devel, and this is similar to Ruby. We'll see this pattern often where we've got a package that includes a program or a library, and then another package that includes development code so that we can compile against that library. And that's about as much as you need to know about it. It's just that usually going through this process, you may run into issues where either installing a gem or another package, you'll get a compilation error. Usually it means that you're missing some library or some development library. So we've got those two. We need a zlib1g devel. And node.js, because Ruby requires Rails requires a JavaScript runtime. And it looks like I typed that one in wrong. Because
I think you accidentally put a 1 instead of big.
Yeah.
Is it 1G?
Yeah, it's lib. These names, they're... you look at them and it just like...
It's not devel, it's dev.
It's dev. Yeah, it's interesting. Sometimes they follow a pattern. Like we've got dev here, but devel here.
Yeah.
So there we go. We'll install that. All right, so we're pretty much good on... on packages for development libraries, and we've got Ruby. What do you think?
Now, Manny, I do have a quick question for you. It is my understanding that Rails needs, well, database. I haven't heard you say anything about that. Is that because it's just going to magically appear, or are there any steps that we need to take for that respective back-end service?
Well, so glad you mentioned that. Strictly speaking, you don't need a database for Rails, but we certainly do, because the apps we're writing, or the app that we're going to write in this series, we're going to want to save our work, and we want to be able to have users store data in a permanent way. Imagine if you had a blog where if the server went offline, your blog disappeared. That'd be pretty awkward. So a database, glad you brought that up, Justin, and just to kind of recap what a database is and why we need one, is that it's basically a program that its only job is to take data and store it for us in a permanent way, so that if the server reboots or files that we create or content that we create become files on a hard drive that can be backed up and can be copied and shared. So again, kind of going with this standing on the shoulders of giants theme, it would be a lot of work to write our own database from scratch. And thankfully, there's many databases that we can choose from and many that will work with Rails. So specifically with Rails, Rails works with relational databases. So we're going to be using SQLite for this series. There also is MySQL, Postgres, some other databases that you can choose. The process for installing these is very similar to what I'm about to show you with SQLite. It's just a different name. And we'll get into this in a later series, but the nice thing about using Rails is that no matter what database you use on the back end, in your application code, we're going to be using the same code to interface with any database that we choose. So let's hop back over to our OS X terminal. We'll come back to Linux in just a minute. And we're going to use SQLite 3. And the cool thing about SQLite 3 on OS X is that just like Ruby and Ruby Gems, it comes already installed on the system. So we don't need to install anything to get SQLite 3. We can test it out the same way that we've done with Rails, with Ruby and Ruby Gem. We can just type in the command to run it and then see what version we have. And we can also run SQLite 3, the program, and we get this client which allows us to kind of mess around with it, see what SQLite's all about. We don't need to do this for anything in this series because Rails handles all this kind of thing for us, but we just want to know that it's here and it's working. So we're all set as far as I do this a lot. Sometimes you type in a package that you and SQLite 3 devel. And I was kind of guessing on there. I do this a lot. Sometimes you type in a package that you think you know, the name should be this, but it's actually not that. So I'm just going to just double check my notes real quick to see what the actual oh, there we go. They put a lib in front of it. So it's lib SQLite 3. Sometimes I feel like the package containers are messing with us a little bit. There we go, and I actually didn't have that installed on my computer, so you can see that it went out and it downloaded them and it grabbed them. So let's test this out on my machine. There we go, so we've got a good terminal, and I can check the version. And forgot the 3 on the end of that. There we go. So we've got a database.
So, Manny, now that we have this database, I feel like we might have all the...
So about this Ruby Gems website is that right there, this name Rails, that's the name of the gem that we need to get. That's how we get Rails. So usually, you'll find out about some cool gem or some cool framework that you'd want to use or try out. What is it? How do I find it? Usually you'll get a package name that you'll see on a page. Like, thankfully with Rails, it's really pretty straightforward, very straightforward name. So let's go ahead and grab that. So with gem, we haven't really talked about the commands we can give to it. And similar to apt-get, we've got an install, we've got an uninstall, and we've got a list command. Those are the main ones that you'll typically use. So here, just running gem list, I get a list of all the gems that I have installed on my computer here. You can see I already have Rails installed. But I can also just look at this and see what I've got, because it keeps track of that for me. So if I wanted to install Rails, all I need to type is gem install Rails. And it's going to think for a bit. It's kind of going out to the internet. It's doing some number crunching, figuring out what it needs. And you see it just says successfully installed Rails. Now, I'm cheating because it's already installed. doing this on your end, you're going to see about 15 or 16 different gems being installed here. And Gem will actually tell us what it's made up, what Rails is made up of. We can do that by using this dep command. So gem dep Rails basically is, we're asking what makes up Ruby on Rails? And look at all these packages we've got. You know, all of these are gems and subgems that we're going to be downloading to get this working.
So Manny, is this going to be exactly the same procedure that we would use in the Linux environment?
Yeah, isn't that great? Ruby and gems, the command line interface is the same on whether you're on OS X or Linux. And I even seen Windows ports of this that have a command line interface where the commands to actually install gems and run Ruby programs is the same. So here in Linux, we'll do the same. We'll do gem install Rails and pull that down here. And it's yelling at me because it's saying I don't have permission to do this because I forgot to run this as sudo with admin privileges. So I'm going to go ahead and do that. And again, it's already installed, so it's showing me that, but we can do the same gem dep command. Everything works the same here in Linux as it does in OS X. So that's we've done it. We've installed Rails.
Now, Manny, I noticed this is Rails version 5.1.
It's the same since Rails 3. So, you know, they've added features and better way of doing things, but you'll be able to follow along with Rails 5 or even older versions if you need to. I definitely would recommend using Rails 5 for this.
No, I'm pretty excited about seeing how this all comes. Grab a copy. We got all the requirements.
You haven't told me what to do. Here we go. What do you want me to do? And you'll see that there's a lot of options, a lot of things to do. But for right now, let's just make a new project. That's what we're here for. So I'm going to do Rails new and new project. Actually, let's do like hello. We're gonna get Rails to say hello. So, and you'll notice I totally